Okay, we're going to talk about what's called a direct variation. A direct variation is a specific relationship in which there is a constant ratio, and I'm going to put in parentheses y over x because we'll talk about that quite a bit. It's a constant ratio of y to x between two variables. This constant of variation, I'm going to highlight this constant of variation, or this constant ratio, is variable k. Direct variation equations are written in the form y equals kx. So let's talk about the constant. Identify the constant of the ordered pairs below, then write a direct variation equation to represent the relationship. So we're looking at these four ordered pairs, 1, 4, 2, 8, 3, 12, and 4, 16. We want to find the constant of variation, and it's very important that you divide these correctly. Recall that an ordered pair is x, y. So we're going to divide the y by the x. We're going to divide the y by the x for each of these to show that there is a constant value. So if you divide 4 by 1, that's 4. 8 divided by 2 is 4. 12 divided by 3 is 4, and 16 divided by 4 is 4. So our constant of variation is 4. And our equation, I'm going to draw an arrow, our equation would then be y equals 4x. We're going to be using this form right here. And what that means is in order to obtain the y, we always multiply your constant value by the x. And it gets a little bit confusing on how to find that constant value, but you just need to remember it's the ratio of y to x. So let's look at number 2. We're going to go ahead and divide our y by our x to find our k. Three divided by -6. This is -1/2. Write it as a fraction if you get a decimal. 2 divided by -4 is -1/2. We're going to talk about this point here. You'll see 0, 0 appear quite a bit within these direct variation problems. And that's mainly because if you look up at the direct variation equation above, y equals kx, you'll notice the y-intercept is always 0. Within these direct variation problems. And that's mainly because if you look up at the direct variation equation above, y equals kx, you'll notice the y-intercept is always 0. Our plus b is always 0. So these equations will pass through the origin, and you will see that point from here or here and there pop up within these ordered pairs. So we're just going to skip over that point. And let's go look at the last point, -1 divided by 2, or -1/2. So we can say that our constant is -1/2. And then the equation for these variables is y equals -1/2 x.
Okay, it's your turn to do the next two. Go ahead and do numbers 3 and numbers 4 just as a warm-up and to remind yourself of how to find the direct variation.
All right, moving down to number 3, always want to divide the y by the x. Just be very careful about that, y over x. So if we divide -8 by -12, you will get positive 2/3. -4 divided by -6 is positive 2/3. Skip over the 0, 0. And then divide the last set of numbers. 2 divided by 3 is 2/3. So we can say that our constant is 2/3, and our equation is y equals 2/3 x. And then number 4, y by x. 12 divided by -4 is -3. 3 divided by -1 is -3. -9 divided by 3 is -3. And -15 divided by 5 is -3. Make sure that you check all the ordered pairs to make sure that there is a constant throughout all the values. So our constant is -3, and our equation is y equals -3x. Let's take a look at identifying equations. We want to identify the equations below that represent a direct variation. If yes, so if they do represent the direct variation, we want to identify the constant of variation. We want to know what is our k. And as a reminder from above, what we're looking for is y equals kx. If we can write it in that form, then we know it's direct variation. We want to make sure that there's the y-intercept is 0, so it just needs to be y equals kx. And if it's not that way, see if you can rewrite it to be that way. So looking at number 5, we have y equals 3x. So we could say yes. So yes, and our constant is 3 right here. Number 6, y equals -4/5 x. This is a yes, and here is our constant. We saw an example of a fractional constant above. I think we had -1/2. So this is yes, and our constant is -4/5. Looking at number 7, y equals 2. Match it up to what we're looking for over here. We need y equals kx. Because this is missing the x, we're going to say no. All right, for number 8, we need this to say y equals. So what we can do on this one is we can divide both sides by 2. And we get y equals 5/2. And I'll bring out the x to the side. So we can say yes. And our constant is k equals 5/2. Number 9, y equals x or 1x minus 4. This one would be a no because of the -4. The y-intercept for all direct variation equations is always 0. So this one would be no. Number 10, y equals -x. Remember that there's always a little hidden 1 right there. So this one would be a yes. And our constant is -1.
Okay, that is enough of a reminder. I think you guys have this down. You already said you had it from your class, but I just wanted to make sure that we had that review. Okay, it is time to move on to inverse variation. So go ahead and turn to that section. It should be just a couple pages ahead, and we will get started there.
Taking a look at what an inverse relationship is. An inverse relationship, or an inverse variation, is a specific relationship in which there is a constant product between two variables. We're going to write product here. And in parentheses, I'm going to put x times y. Between two variables. This constant of variation is variable k. So the constant of variation is also k. Inverse variation equations are written in the form y equals k over x. Identify the constant of the ordered pairs below, then write an equation to represent the relationship. So what we need to do to find the constant is to find the constant product between all ordered pairs. So taking a look at number 1, 1 times 20 is 20. 2 times 10 is 20, and 4 times 5 is 20. So we can say that our constant here is 20, and the equation is y equals 20 over x. For number 2, we go ahead and find our product. 1 times negative 28 is negative 28. 2 times negative 14 is negative 28. And 4 times negative 7 is also negative 28. And you do want to check all those ordered pairs to make sure that that is constant throughout. And if it's not an inverse variation. So our constant is negative 28. And our equation is y equals negative 28 over x.
Okay, you guys can go ahead and work on numbers 3 through 6 independently, or you can help each other. And then we will next look at identifying whether an equation represents an inverse variation.
Going down, we want to find the constant product. So we have negative 8 times negative 6.5. So if you take negative 8 and multiply by negative 6.5, you will get 52. Negative 4 times negative 13 is also 52. And negative 2 times negative 26 is 52. So our constant is 52. And our equation is y equals 52 over x. I'm going to skip by number 4 and let you try that one on your own and jump down to number 5. These order pairs are given in a table, but the concept is the same. We want to go ahead and find the product of these variables. So if we multiply negative 5 times 2.4, you get negative 12. Negative 3 times 4 is negative 12. Negative 2 times 6 is negative 12. And negative 1 times 12 is negative 12. So we verified the constant product throughout the ordered pairs. So that is our constant. And our equation is y equals negative 12 over x. Looking down at the next set, we want to be able to identify equations. So recall from above at the top of the notes, the equation for an inverse variation is in the form y equals k over x. So I'm going to write that to the side over here because that's going to be important. We need to see, can we write the equation in this form, or is it already written in that form, or can we solve for y and see if it's in the form? Number 7, we have y equals 50 over x. So this is in the form, so this is yes. And we want to identify the constant of variations. I'm going to put in parentheses, our constant is 50, right up here. Number 8, y equals 3x. This would be a no because the x needs to follow this exact same pattern. So that's actually a direct variation from the previous lesson, y equals kx. So this is no. Okay, so that is not direct. That's actually, that's not inverse. That's actually direct. Number 9, xy equals negative 14. You need to solve for y if these are not already solved for y. So I'm going to divide each side by x. We get y equals negative 14 over x. So this is a yes. And our constant is negative 14. Number 10, y over x equals negative 6. Let's go ahead and solve for y. So let's multiply both sides by x. So we get y equals negative 6x. Taking a look at this, it is not y equals k over x. So this is no, not an inverse variation.
Okay, we're going to do a couple more of these. Numbers 11 through 14 are for you to practice. They do get a little bit tricky, but if you work together, I think that you can figure out if they are an inverse variation or if they're not. Remember, you might have to do a little bit of work to get them in the right form. I'm sorry about that beep. My partner texted me and it came up on my computer. Apologies for the interruption. But here we are going to now go over number 11 through 14.
Number 11, we are solving for y. You're always solving for y, and you want it to be just like this in order for us to say yes. So looking at number 11, we have 2xy equals negative 40. So if we divide both sides by 2x, we get y equals negative 40 divided by 2 is negative 20. And we're going to leave that x down there. So this is a yes. And our constant is negative 20. Number 12, we go ahead and divide both sides by 7 to get our y equals. 28 divided by 7 is 4. You notice that x is in the top, so we want to leave that in the top. So this is no. That's actually a direct variation. Number 13, x over 9 equals 8 over y. Let's go ahead and cross multiply since this is a proportion. So we have xy equals 9 times 8 is 72. And then divide both sides by x.
I'm going to go ahead and back that up a little bit just in case some of you missed that, the way that she was handling this.
And cross multiply since this is a proportion. So we have xy equals 9 times 8 is 72. And then divide both sides by x. Y equals 72, and then you have the x in the bottom. So this is a yes. And our constant is 72. And number 14, we're going to solve for y. Before I do that, let's multiply by x to get that out. So we get $20 equals negative 4xy. And divide both sides by negative 4x. So we get y equals, I'm going to bring that over here, 20 divided by negative 4 is negative 5 over x. When x is in the bottom, we want to keep it in the bottom. So this is yes. This is an inverse variation, and our constant is negative 5. And let's take a look at finding missing values in an inverse variation. So if we know that, or if we're told that ordered pairs are part of an inverse variation, we can find a missing value by knowing that the ordered pairs will have that constant product. So if x times y is a certain value in the first order pair, then you know that it has to be the same product in the other ordered pair. So we did this very similarly with direct variation, where we did the constant ratio of y over x equals y over x. So now we're going to do it with inverse variation with xy equals xy. So for number 15, we have 12, 14, and negative 24y. So we can multiply our 12 times our 14. and set that equal to negative 24 times y. Twelve times 14 is 168. And then if we divide both sides by 24, or negative 24, we know that y equals negative 7. Okay. I'm going to skip around and do some of these and leave the other ones for you to do. Let's look at number 18. We have x and negative 7 and 21 and negative 3. So if we multiply negative 7 and x, we get negative 7x equals, you want to multiply 21 times negative 3, which is negative 63. And divide both sides by 7, negative 7, we get x equals positive 9. Let's go down to 19. Let's go down to 19. If y equals 9 when x equals negative 6, find x when y equals 3. I get a little bit lost in these sometimes when they're wordy, so I really like to set them up as ordered pairs. So we have x is equal to negative 6 and y is equal to 9. And for our other ordered pair, we're looking for the x, but we know the y is 3. So using our products, we have negative 6 times 9 equals 3x. So negative 54 equals 3x. Divide both sides by 3, and we get x equals negative 18. And let's go ahead and look at number 20. For number 20, if y equals 16 when x equals negative 3, so let's do negative 3 and y is 16. Find x when y is negative 6.
Go ahead and try that now before she explains the rest.
We go ahead and find our products. We have negative 3 times 16 equals negative 6x. So negative 48 equals negative 6x. Dividing both sides by negative 6, we get x equals positive 8.
Okay, so your first piece of homework to complete before I see you next is to finish the problems on these pages that you have not yet completed. So definitely 21 and 22 and any ones above that you have not yet completed. I want you to go ahead and circle those right now and mark those as homework. So I'll give you a minute to do that before we move on.